Imagine looking up at the night sky and realizing that what you're seeing shouldn't even exist. That's exactly what astronomers felt when they stumbled upon something so bizarre, so utterly against the odds, that it was first dismissed as a glitch. Meet 3I/ATLAS, the interstellar object that both the Hubble Space Telescope and the James Webb Space Telescope had no business finding, and yet they did. And trust me, by the time we're done, you'll be questioning how fragile our understanding of the universe really is. Before we dive in, if you love mind-bending discoveries like this, hit that like button so YouTube knows you're not just here to watch cat videos. And hey, subscribe if you want a front row seat to the universe's greatest mysteries. Now let's set the scene. You might remember Oumuamua, that odd cigar-shaped visitor from another star system discovered in 2017, or comet Borisov, the second confirmed interstellar object in 2019. Both were one-time only guests, flying through our solar system on hyperbolic trajectories, never to return. But then came something new, 3I/ATLAS, the third confirmed interstellar interloper. And here's the kicker. Unlike its predecessors, 3I/ATLAS was discovered in the middle of breaking apart. Not only did it not follow the rules of what astronomers expected, it basically tore the rule book into confetti and scattered it across the cosmos. But wait, how did Hubble and James Webb even get involved? These telescopes are usually busy with galaxies, exoplanets, and peering into the dawn of time itself. So why point them at a tiny, faint speck tumbling across the solar system? Simple, because this speck came from somewhere else entirely. When something from outside our solar system comes barreling through, every telescope in the neighborhood wants a piece of the action. It's like spotting a stranger crashing a family reunion. Everyone turns their head. Here's where the impossible part comes in. Interstellar objects are incredibly hard to spot. They move fast, they don't hang around for long, and they're usually dim. Most of them never get noticed at all. In fact, experts believe that for every interstellar object we do detect, thousands more slip through undetected. So the fact that astronomers caught 3I/ATLAS, and that it happened to disintegrate just as our most powerful telescopes were watching, that's like winning the lottery while being struck by lightning, and then having Morgan Freeman narrate it. The discovery came courtesy of the Asteroid Terrestrial Impact Last Alert System, ATLAS, in April 2020. ATLAS is a survey project designed to catch near-Earth asteroids before they crash into us. You know, the kind of thing Bruce Willis deals with in movies. But instead of a planet killer, Atlas flagged a faint fuzzy dot that didn't behave like a normal comet. Its trajectory screamed outsider. Calculations confirmed it. This object wasn't born in our solar system. It was just passing through, carrying secrets from a star system light years away. Now here's the wild twist. 3I/ATLAS wasn't just an interstellar comet, it was a fragmenting interstellar comet. By the time astronomers got their best instruments locked on it, the thing was literally falling apart, breaking into chunks as sunlight tore at its fragile structure. That alone makes it special, because it's the first interstellar object humanity has ever observed disintegrating in real time. Imagine getting a front-row seat to a cosmic visitor's final moments. And this is where the Hubble Space Telescope comes into play. Even after decades in space, Hubble still has a sharp enough eye to capture the breakup of 3I/Atlas. Astronomers used it to track how the fragments drifted apart, like cosmic breadcrumbs. What they found was almost poetic. The pieces were separating gently, suggesting that the comet wasn't solid rock at all, but a loosely held together clump of ice and dust, fragile as a snowflake in the sun. But then came James Webb. This telescope wasn't even designed to chase comets, let alone ones from another star system. Yet, with its infrared vision, Webb could peer deeper into the chemistry of the fragments, analyzing what 3I/ATLAS was really made of. And here's where things got truly fascinating. Because this object didn't just look different, it was different. Pause for a second and think about this. Every time we find an interstellar object, we're literally sampling material from another planetary system. That's like someone handing you a bottle of water and saying, "Oh, this? It's from a planet orbiting a star 50 light-years away. It's not just rare, it's almost impossible. And yet, thanks to Atlas, Hubble, and Webb, we had one of those samples drifting through our backyard. And that's just scratching the surface of what makes 3I/ATLAS so bizarre. Up next, we'll dig into what the telescopes actually uncovered, the chemistry, the structure, and the clues it carries about alien solar systems. Spoiler, it challenges what we thought we knew about how planets and comets even form. But before we get there, hit subscribe and turn on notifications so you don't miss the next chapter of this impossible cosmic detective story. Because trust me, it only gets weirder from here. When Hubble first locked onto 3I/ATLAS, astronomers weren't sure what to expect. Was this just another faint speck, barely noticeable against the backdrop of stars? Or was there something more exotic hiding in the data? What they got was stranger than either option. Instead of one neat little comet nucleus, they saw a trail of fragments drifting apart like a shredded cosmic snowball. The fragments were surprisingly gentle in their separation. Normally, when comets break apart, it's violent. Sudden jets of gas blast chunks into space like a champagne cork flying across the room. But 3I/ATLAS was different. Its breakup looked more like someone quietly letting go of a handful of powdered sugar in zero gravity. This told scientists something huge. The comet was held together so loosely that just the soft touch of sunlight and gravity from the sun was enough to tear it apart. Now, this detail may sound small, but it has massive implications. It suggests that 3I/ATLAS formed in an environment far colder and less violent than our solar system. Think of it as cosmic archaeology. By watching how this object behaved as it crumbled, scientists were essentially peeking into the climate of an alien star system billions of years ago. But Hubble could only show us the breakup. To really get under the skin of this interstellar visitor, astronomers turned to the James Webb Space Telescope, the most powerful space observatory humanity has ever built. With its infrared sensors, Webb could do something Hubble couldn't. It could analyze the chemical fingerprints hidden in the light bouncing off 3I/ATLAS. Here's where things get wild. Webb detected that the comet's fragments contained a surprising abundance of carbon monoxide gas. For context, that's not what you'd expect in such high quantities from a typical comet in our solar system. In fact, 3I/ATLAS seemed to be almost overloaded with the stuff, and that raised eyebrows, because carbon monoxide is highly volatile. It evaporates easily in the presence of heat. So for 3I/ATLAS to still be holding so much of it after traveling through interstellar space, that means it had to form in a place so cold and distant from its home star that the gas could freeze solid in its ices. That discovery alone is like finding a fingerprint from another solar system. It hints that 3I/ATLAS may have come from the farthest, coldest outskirts of its home, maybe a region similar to our own Oort Cloud, the icy shell that surrounds the sun at unimaginable distances. Except this wasn't from our Oort Cloud. This was someone else's. A star system light years away essentially tossed us a sample of its frozen leftovers. And that's not all Webb found. Early analyses suggested that 3I/ATLAS chemistry was not entirely alien to us. While it carried exotic features like extreme carbon monoxide levels, it also shared many of the same ingredients found in our local comets: water ice, dust, and organic molecules. That's mind-blowing, because it suggests that the process of building comets might be universal. Across the galaxy, star systems might be cooking up icy wanderers using the same recipe, a cosmic hint that planetary formation follows a common playbook. Let's pause here for a second. Think about what that means. Every time we detect one of these objects, we're not just finding a rock or a ball of ice. We're finding direct evidence that other planetary systems out there work a lot like ours. That's a huge clue in the quest to understand how common Earth-like worlds might be. But of course, science always likes to throw in a curveball. 3I/Atlas was also frustratingly fragile. By the time Webb and Hubble were analyzing it, much of the nucleus had already disintegrated. Instead of a solid target, astronomers were basically chasing a cloud of cosmic dust. That made measurements tricky, like trying to analyze the DNA of a dinosaur while it's actively turning into smoke. Still, the data Webb collected was revolutionary because it gave us the first ever detailed chemical profile of a disintegrating interstellar comet. And here's the kicker. This object wasn't just interesting because of its chemistry. It was interesting because of timing. If Atlas hadn't spotted it early, if Hubble hadn't tracked its fragments, and if Webb hadn't been in its prime, we never would have caught this thing in the act. The universe basically lined up the perfect scientific ambush. Imagine a baseball flying past you at 60,000 miles per hour, and somehow, by sheer coordination, every telescope in the solar system managed to take a snapshot of it before it disappeared forever. That's what happened with 3I/ATLAS. This impossible alignment gave astronomers something they rarely get: a chance to connect the dots between what comets are like here in our solar system and what they might look like light years away. And the evidence was clear. While the environments may differ, the building blocks of comets, and perhaps even planets, might be shared across the galaxy. That's where things get really exciting, because if comets like 3I/ATLAS are common, then maybe the conditions for life, the delivery of water, carbon, and organic molecules to young planets, are not rare accidents, but a galactic tradition. So the big question is this: how often do these cosmic messengers swing by, and what secrets are still hidden inside them? Stick around, because the deeper we dig into the mystery of 3I/ATLAS, the more it reshapes how we think about the galaxy and our place in it. So here's the big picture. Every comet we've studied in our own solar system is like a postcard from the early days of the sun. They preserve ancient ice and dust from billions of years ago, giving us a chemical snapshot of what things were like before planets fully formed. Now imagine having not just postcards from home, but postcards from other star systems. That's exactly what 3I/ATLAS represents. Its chemistry tells us it was born far from its parent star, in a region so cold that fragile gases like carbon monoxide could freeze solid. That detail hints at something remarkable. Distant solar systems likely have their own outer freezer zones, just like our Oort Cloud. In other words, the structure of planetary systems might be more universal than we thought. And that's a game changer. Because for decades, scientists debated whether our solar system was unique. Was our arrangement of planets, comets, and asteroid belts a cosmic fluke, or part of a common pattern? 3I/ATLAS gave us evidence that we're not that special. Planetary systems across the galaxy may all play by similar rules. Small rocky worlds close in, giant gas planets farther out, and icy bodies pushed to the edges. But here's where it gets even more fascinating. Comets aren't just frozen leftovers. They're cosmic delivery trucks. Billions of years ago, they likely slammed into Earth, dropping off water and organic molecules, the raw ingredients for life. If 3I/ATLAS is anything to go by, then other solar systems are also filled with comets carrying the same ingredients. That means life's recipe isn't confined to one corner of space. The same chemical seeds may be scattered everywhere, just waiting for the right planet to take root. And think about the sheer scale. Our galaxy alone holds hundreds of billions of stars. If most of those stars have planetary systems, and most of those systems have comets, then interstellar objects like 3I/ATLAS aren't just rare curiosities. They're ambassadors. They drift between stars, carrying traces of their home systems, and sometimes, if luck allows, they wander close enough for us to catch them in action. The odds of us spotting one in the middle of breaking apart while both Hubble and James Webb were online feel almost too perfect. But this isn't just a story of luck. It's a reminder that the universe is constantly throwing surprises our way, and every once in a while we're in the right place with the right tools to capture them. Now here's the twist. If 3I/ATLAS was fragile enough to disintegrate so easily, how many others like it have already slipped through unseen, crumbling silently in the void? For every one we catch, countless more probably pass undetected. That means the galaxy is teeming with these icy messengers, most of them invisible to us, which raises the obvious question, what else are we missing? And that brings us to an even deeper mystery. If interstellar comets are common, and if they carry water and organic molecules, then could they act as carriers of life's building blocks across the galaxy? This idea, known as panspermia, suggests that life, or at least the ingredients for it, might not originate in just one place. Instead, it could be seeded from system to system by comets like 3I/Atlas, spreading potential for biology far and wide. That's not science fiction. It's a hypothesis serious scientists consider, and discoveries like this only fuel the debate. Because if comets in completely different solar systems share similar chemistry to ours, then maybe life's potential isn't an Earth-only phenomenon. Maybe it's a galactic tradition. And here's where curiosity spikes. If comets are universal, and if they scatter organic molecules across the cosmos, then the leap from chemistry to biology might not be as rare as we once feared. So what happens next? Well, the universe didn't just give us one postcard. Objects like 3I/ATLAS will keep showing up. Maybe next year, maybe in a decade. The question is whether we'll be ready, with telescopes sharp enough and fast enough to capture their secrets before they vanish forever. Here's the crazy part. If you zoom out and think about the odds of us even seeing 3I/ATLAS, it starts to feel almost impossible. Astronomers estimate that our solar system is constantly being visited by interstellar objects, but most are so faint and fast-moving that they escape detection. In fact, for every one we've caught, Oumuamua in 2017, Borisov in 2019, and now 3I/ATLAS, there are probably thousands we've completely missed. They slip in, swing around the sun, and fly back into interstellar darkness without ever showing up in a telescope's crosshairs. That's why this discovery shocked scientists. Not only did Atlas manage to catch 3I/Atlas in time, but both Hubble and James Webb happen to be available to study it. Think about that lineup for a second. You've got a telescope launched in the 1990s, still working against all odds, and a brand new space observatory a million miles away, both turning their gaze on the same fragile comet, right as it was falling apart. That's not just lucky, that's jackpot lottery lucky. And here's where things get even weirder. Interstellar objects move on hyperbolic orbits, which means they don't circle the sun. They just pass through once and vanish forever. Astronomers have days, maybe weeks, to spot them before they fade into the cosmic background. In the case of 3I/ATLAS, the window was razor thin. By the time Webb got its instruments pointed at it, the comet was already crumbling into dust. If it had broken up just a little sooner, or if the telescopes had looked a little later, this discovery would have been lost to history. The timing is almost suspiciously perfect, and some scientists half-jokingly say, the universe just wanted us to see this one. Because not only did we catch an interstellar visitor, we caught one in the act of disintegrating, something that had never been witnessed before. Imagine trying to study an alien artifact that self-destructs the moment you look at it, and somehow you manage to record every step of its breakup in high definition. That's exactly what happened here. But it's also a humbling reminder. If 3I/ATLAS was that fragile, how many others have come and gone without leaving a trace? Our telescopes are improving, but they're still not sensitive enough to catch every visitor. Statistically, dozens of interstellar comets could be cruising through the solar system right now, completely invisible to us. The idea that we're surrounded by messengers from other stars, most of them slipping past unnoticed, is both thrilling and frustrating. This rarity is what makes every detection priceless. Each one is like finding a bottle floating in the ocean, carrying a note from a distant shore. With Oumuamua, we puzzled over its strange shape and motion. With Borisov, we finally confirmed an interstellar comet that looked more like the ones we know. And with 3I/ATLAS, we got front-row seats to the chemical and structural breakdown of an alien snowball. 3 objects, 3 wildly different stories. and together they paint a bigger picture of just how diverse the galaxy really is. But there's another angle to this rarity. The more interstellar objects we detect, the more likely it is that someday one will pass close enough for a mission. Imagine sending a spacecraft to chase down an object like 3I/ATLAS before it leaves, capturing samples or even bringing pieces back to Earth. That's not science fiction. NASA and other space agencies have already started sketching concepts for interceptor missions, spacecraft that wait on standby, ready to launch at a moment's notice when the next visitor is spotted. If that sounds ambitious, it is. But think about the payoff. An actual piece of material from another solar system, physically in our laboratories. Not just data from telescopes, but rock, ice, and dust forged under a different star, sitting under a microscope here on Earth. That would change astronomy forever. 3I/ATLAS reminds us why it's worth preparing. Because these objects don't come with a schedule. They don't wave hello. They just show up unannounced. And if we're not ready, they slip away forever. This time, the universe cut us a break. Next time, we'll need to be faster. So here's where it all comes together. 3I/ATLAS wasn't just another space rock. It was a visitor from another star system, fragile enough to fall apart, yet generous enough to reveal its secrets right before vanishing forever. In the span of a few short weeks, it gave us a chemistry lesson from an alien solar system, a glimpse of how universal comets may be, and a reminder that the galaxy is far more connected than we once imagined. Think about it. Tiny, icy bodies like this one may have carried water and organic molecules across light years, scattering the seeds of life wherever they land. Earth may not be the product of one lucky roll of the dice, but part of a much bigger cosmic pattern, one that repeats itself across the Milky Way. And the best part? This is only the beginning. Oumuamua, Borisov, Atlas. That's 3 discoveries in just the last few years. As our telescopes get sharper and our detection networks expand, we're going to see more of these wanderers. Each one will bring a new clue, a new puzzle piece, maybe even a new challenge to what we think we know about life, planets, and the universe itself. So the next time you look up at the stars, remember this. The space between them isn't empty. It's alive with travelers, fragments of alien worlds silently drifting, waiting to be noticed. And every once in a while, if we're lucky, one of them stops by and whispers a secret before disappearing forever. If you enjoyed unraveling this mystery, make sure to like, subscribe, and share this video with someone who loves space as much as you do. Because discoveries like 3I/ATLAS remind us that the universe is still full of impossible surprises. And we've only just started listening.